Hello YouTubers and fellow hams. Well, I've got a new toy to play with. A really awesome piece of test gear. Holy cow, this thing's great. And what is it? It's this. The miniVNA Pro Vector Network Analyzer. This little device is amazing. Okay, it's a network analyzer. So, what is a network analyzer? Well, let's take a look at that. Here's a web page on Wikipedia about network analyzers. And as it states right up here at the top, a network analyzer is an instrument that measures the network parameters of electrical networks. It measures all kinds of things. It can measure reflected things like SWR, complex impedance, all kinds of various parameters of a network. Anything you'd want to measure. You can sweep a filter network with a frequency and see how its impedance varies over frequency. It's the kind of thing I was wanting to do. I was on the way of building one using a SI5351 breakout board and an Arduino, and I was wanting to automate measuring things like impedance, and doing math to calculate SWR and such with it. But I was slow going with that, and one of the problems was that the SI5351 outputs a square wave, which just gets downright nasty when you're trying to measure stuff. Lots of harmonics. A real network analyzer, it uses the sine wave. It uses a very precise signal source, very precise measurements, highly calibrated, an extremely powerful device. Well, my project kind of went by the wayside when I was sent this miniVNA Pro. And by the way, thank you very much, Stephen. Greatly appreciated. I'm going to use the crap out of this thing. So, a network analyzer is a powerful piece of equipment. If you're designing antennas, if you're designing filter networks, if you're working with just about anything radio related, it can measure the length of a feed line. You can find a fault in a feed line using it. Just all kinds of stuff. So this miniVNA Pro is made by Mini Radio Solutions. It is a small portable device. This thing has inside of it a battery, a lithium-ion battery, so it can be used in the field. It connects to your computer via USB here, and this can also be used to charge the device. This is an accessory connector for other products. I don't know what they've released for it, but it's for hooking other things up to it. A little reset button. Yeah, right here, little reset button to reset it, and a power switch. When you plug it into USB, it powers up via the USB. If you were using it portable in the field, and we'll get to how you do that, you'd flip this switch to turn it on, and that's how you'd operate it. So this is the hardware, and it has a USB connector. What about software? I know I keep looking down that way. I'm looking at my my monitor to make sure I'm in frame, and I'll try to keep staring at the camera so it feels like I'm talking to you. So anyway, software. Well, they provide, if you go to the download software link here, they provide, now it knows that I've already got it installed on my Android phone. We'll get to that. That's really cool. But they provide software in the form of a Java application. That's brilliant. Doing it in Java. Java is an interpreted language, and there's interpreters for just about every platform that's out there. Windows, Macintosh, Linux, Raspberry Pi. There's Java interpreters for older systems too. I think there was even one made for the Commodore Amiga recently. So Java runs everywhere universally, and that was brilliant of them to do their software in Java. Now, when you plug the device in to your USB port, under Windows and Macintosh, you'll have to go out and download a serial driver for the chip that's in here. I haven't done that because I'm running Linux, and most all of those USB serial connector chips are already supported. So I just plugged this in, and it was recognized immediately, and there was a serial port created under dev/tty USB 0, which is the standard serial port naming convention for USB serial devices. So Linux, plug it in, you're ready to go. You do have to download the Java software though. Now, since it's Java, you need an interpreter to run it. So under Linux, if you go into Synaptic Package Manager and you search for Java runtime, and you scroll down, you'll find this OpenJDK-8 JRE, Java Runtime Environment, JRE. And you'll want to check the green box to install that. And that will install your Java runtime. And from that point, you are ready to go with their software. Now, this is the software that you get when you download it. And this right here, VNAJ version number .jar, Jar, is the actual application. A jar is a package that contains all of the software necessary for that application to run. And after I've installed my Java runtime, I'm ready to run this. So let me plug this into my USB cable so we can run the software. Okay, plugged it in. Little green light came on to show that it's powered up and ready to go. So I will right-click on this jar file and select Open with OpenJDK runtime, Java runtime. And the software pops up, and we are ready to rock and roll. Now, still coughing occasionally from the chest infection a few weeks ago. The first time that you run this software, it's going to want to calibrate your unit. It creates a calibration file that it uses so it knows, the baseline for the unit, because every unit's going to be a little bit different in the electronics. You need to calibrate it. And they provide you with these little calibration plugs here. There's 3 of them, and they're engraved on the sides. They're little SMA plugs, and they're engraved on the sides with open, short, and load, which is a 50 ohm load. The calibration steps, and I'll open the dialog here so you can see it. Here's the calibration dialog. And there are 4 calibration tests that you can do. These first 3, read open, read short, and read load, use the included calibration plugs. Read loop, you would need a loopback cable to go between the 2 connectors. Now, the device has 2 connectors here on the end, labeled DUT and DET. DUT, this one, is device under test. When you're doing reflectivity tests like SWR or reading complex impedance, that's the connector you'd use. If you were going to measure a filter circuit, you'd want to have this on the input and the output. So DET would go to the input of your circuit, DUT would go to the output of your circuit, and then this could transmit a signal through your circuit and measure its impedance, well, I'll show you the list of things that it can measure. Actually, let's do that right here. If I pull up the user's guide, it's a very comprehensive manual, and it really goes into detail about all the things you can measure with the software. If I pop up here to page 15, these are our measurements and an explanation of what they are. And we have return loss, phase, signal phase, transmission loss, phase of the signal for transmission measurement. So I guess that shows you the phase of the signal transmitted and received in the relationship between the two, so perhaps phase shift. Our absolute value of the transmission sensor, I don't know what that means. I'll have to read some more about the manual. SWR, we know what that is. Z is complex impedance. So these are the two measurements here that you'd probably rely on the most in working with radio circuits. The SWR if you're measuring an antenna, and the impedance of a circuit. Series equivalent resistance of the load, which is DC resistance, equivalent DC resistance. Series equivalent reactance, theta or angle of phase. Group delay, not sure, but I've got more to read in this manual. It's a big manual. So it can measure quite a few things, but like I said, the most common things you'd probably use it for in the ham radio hobby is SWR and Z impedance, complex impedance measurements. Okay, so yeah, nice manual. Calibration. Did I cover calibration? I might have had my face in the way. The calibration window, you plug in those little calibration blocks and you can read open, short, and load to make the measurements. And then once you've made your calibration measurements, you'd hit the save button down here to save the calibration for your device. Now, in Linux, if I go to my home folder, I find a folder named VNA J3.1, and that is where it stores all of its data. It's calibration data. Any images you export, you find it in your home directory. I'm not sure where it stores it under Mac and Windows. Under Mac, it's probably in your home folder. Under Windows, I think that there's a My Documents or My Data folder that you'll probably find it at, but you'd have to look that up in the manual. So once I've calibrated it, it's going to store my calibration in that folder. Now, if I wanted to use the device on another computer, instead of going through the calibration again, I could just copy this folder into the home folder on that other computer, and the calibration data will be right there with it, so that when I run the software, it won't have to be calibrated. Same with Raspberry Pi. I could drag this or copy this folder into my home folder on my Raspberry Pi, run their software, and it's already calibrated. So that's how you can save a step there. Once you've calibrated it once, make a copy of that folder and put it on the computers that you want to use the device with. One exception being cell phones, but we'll get to that. So that's, you go through calibrations, you've got the device calibrated, and you're ready to start making measurements. Now, to test or to demo this, I'm going to hook the device up to my 20-meter dipole. I've got an attic dipole, so hang on a second, I'll be right back. Okay, so now I've got the device hooked up to my 20-meter dipole, my attic dipole. The very basic, simple way to make measurements with this thing is it'll display two measurements at the same time. So I'm going to set this one to be SWR in green, and I'm going to set this one to be impedance in teal, cyan, whatever that color is. And here up here in the right corner is frequency. So I'm going to tell it I want to sweep from, let's say, 13.9 megahertz to 14.4 megahertz. Oops, 14.4. Okay, so that's the frequency range I'm going to sweep. And down here is mode in the lower right. Reflection or transmission. Transmission would be if you were measuring a filter. You'd transmit through the filter, but we're measuring reflection since we're just hooked to an antenna. And I'm going to hit single scan. And it's going to do a scan, and then it's going to graph my results. Let's do this again a little bit bigger. There we go. Pardon the little noise spikes. I have a long USB cable running past the monitors, so I'm sure it's picking up a little noise from those. But as we can see here, green is SWR, and I think my antenna is a little bit long. I'm going to have to go up there in the attic and trim an inch or so off the ends because it's lowest SWR right here. And if I click, I'll put a marker there, and then you can come down here and you can see your readings where that marker is. So I've got an SWR of 1.05 to 1 at 14.011 megahertz. If I get up here to 14.050, the SWR has climbed to 1.14 to 1. If I get up here into the sideband portion, it's just rising right up, and by the time I get to 14.250, I'm at 1.64 to 1. At 14.3, I'm at 1.86 to 1. So this is really powerful. I had originally tuned my antenna using an old MFJ analyzer, which was probably a little bit out of calibration. And I thought that my lowest SWR was at 14.15, but apparently no, my antenna is still just a little bit long. And then the blue graph here shows our impedance, and there's the scale on the side, and so I can see that at 14.011, where my SWR is low, my Z is 52.6 ohms, which is just fine. So this is one heck of an antenna analyzer right off the bat. What about transmission testing? Well, I'm going to try to go down to the bench. My back is still hurting. I injured it just a couple days ago, but I'm going to try to go down to the bench and measure the impedance of a circuit. Well, I guess I pushed it a little bit much, but I came down here to the bench and to come up with something to measure, I took my, ow, man, I should not have tried the stairs today. My back just went out again. But as long as I'm here, I might as well get this filmed before I hobble back upstairs. This is my QRPP transmitter, my Flea Power 120 milliwatt CW transmitter, from a video a while back. And in that, I have a filter on the output right there to eliminate or cut back on the harmonic, the first order harmonic and second, third harmonics. And that was calculated and then measured with a scope and a signal generator, and I thought I was pretty close. So I duplicated the filter here on the breadboard, and I hooked, using a couple of probes, I hooked up the miniVNA, and I first swept with the probes connected to each other just to establish a baseline, and it was nice and flat. I mean, there's loss in the probes. I saw a nice flat negative 30 dB right across the HF spectrum, but it was flat, which was what was important. So I hooked it into the circuit, and I just did a scan, which I'll throw up on the screen here. And as you can see, I missed the mark on the filter. I could have used one more turn, I think, on that inductor. And the bandpass point on the filter, which I've marked with marker number 1 there, is actually 8.658 megahertz instead of 7. Darn it. Back at 7.1 megahertz, where the oscillator is 7.122, I'm seeing a negative 55 dB. But by the time you get up to the first harmonic at around 14 point something, close enough, it is negative 64 dB. So the filter in my QRP transmitter is off. I could probably use one more turn on that inductor to get its bandpass down to where it needs to be. So this would have been very useful to have when I was designing that transmitter. As you can see from the plot, it's pretty precise. You know, I'm sweeping 1 to 30 megahertz there, and you can see right where the filter's bandpass peaks at 8.658 megahertz. So, yeah, wish I had this back then, but there you go. That's definitely one area where this miniVNA is very, very useful for measuring. So, right off the bat, this is just a massively powerful piece of test gear. Now, there's all kinds of other things you can measure with it, as I said. I've yet to explore those. There's other options in the software to display Smith charts. You can export your graph as a JPEG image if you wanted to use it in a publication. So yeah, the software is really something. I've got a lot to learn looking into it. But one other neat thing about this is it's portable. Remember I said it has a battery? It also has Bluetooth. So if I flip this switch on, you know, it's running off its battery now, and you'll see this little light starting to blink down here. That's telling me that it's looking for a Bluetooth device. Now there is an application for Android. I don't know if there's one for iOS as well, but there is a really nifty little cell phone application here. So I'm going to get my camera and try to position it so that I can show you this. And using Bluetooth, we're going to make the same measurement we just made with the software. We're going to check my antenna, but we're going to check it completely portable using the cell phone. Well, this is my first time trying to capture the cell phone on camera, so hopefully this will work out. But this is the cell phone application. It fills the full screen. Over here are your different types of measurements you want to make. There's a menu, if you tap this, where you can choose what you're going to be doing: reflection, transmission, Smith chart, generator, it'll do a frequency generation, cable measurements, XLCR. And then you can do all the usual stuff. Now again, with the cell phone, the first thing you'd have to do is calibrate the device. The first time you run this, it's going to want to create a calibration profile. So you have to go through those steps. I already did that on this. So we're just going to do reflection measurements. I'll pick reflection up here. Over here I'm going to display SWR. Now there's a frequency button. If I tap that, it comes up with presets for the different amateur bands. And I know I'm measuring my 20 meter dipole, so I'll pick 20 meters to set the frequency range that it's going to scan. And we're set for SWR. I'm going to turn off that. I just want to measure SWR and impedance too. Let's do impedance as well. And I'll hit run. And it's talking to the device, which is over there hooked up to my antenna. And there we go, an SWR curve and a impedance curve. And I can zoom in. And again, I can see that my SWR is lowest right around 14 megahertz, and then goes up. So in the field, this would be one heck of an antenna analyzer to have in the field, wouldn't it? And you can make all the measurements you made connected over Bluetooth, and the device is over there, a good 8 feet away, 9 feet away, hooked up to my antenna, and we're talking to it with Bluetooth. So there you are. That's awesome. What else can I say? You know, if you have your cell phone in the field, all you need to do is bring that device along, and you can check your antennas with a graphing analysis, without having to have a big bulky antenna analyzer in your pocket. That thing's pretty small. So that's a quick look at the miniVNA Pro. This is an amazing little device, and you will be seeing it again. I'll be using this thing to death. I'll be using it in circuit designs. I'll be using it for antenna projects. I'm sure I'll find all kinds of uses for what it can do for measuring things. So you'll see it again. Once again, thank you very much, Stephen, for sending me this device. I just bought an MFJ antenna analyzer maybe a week before this arrived. I'm not going to need it. Now I've got a brand new MFJ antenna analyzer with fresh batteries in it that's had 5 minutes of use that I think I'm going to end up returning it if I can. If not, I'll be selling it, because this is going to do everything that I would ever do with that in a much smaller, much more convenient package. They're a little pricey. I looked this up. They sell for around $489, I think. But it is a pretty versatile and high precision piece of test gear, so I can kind of see that. But I think it's definitely worth having. Yeah, what else can I say? Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.